Hello dears, my name is Subhash Tiwari. I'm going to discuss one of the very important portion of solution chapter. The name of point is want of factor. Want of factor is very important in JEE NEET exam. To understand it better, you must have to clear colligative properties of the solution. Okay. In colligative properties, you have studied uh, the elevation of boiling point, depression freezing point, yeah, relative lowering vapor pressure, osmotic pressure. Okay, these all are depends on means a number of solid particles irrespective of their nature. Okay, so what is the condition of colligative properties? The condition is that the solid particle uh, should not be associate in the solution. If a solid particle associate, then the experimental value of colligative properties will be different from normal, means a calculated value of colligative properties. Okay, so the ratio of observed colligative properties and normal colligative properties is a called want of factor. Okay, the want of factor give the relation between the observed colligative properties and means normal colligative properties. So in this video we will discuss about uh, where we want of factor apply and how do we calculate the want of factor. Okay, the want of factor I is equal to observed colligative properties upon normal or calculated normal colligative properties, right? So observed colligative properties, this is because of the association or dissociation of the solid particles. Okay, so another relation want of factor I is equal to number of solid particles after dissociation or association upon number of solid particles before association and dissociation, right? If number of particles, suppose that if number of particles dissociate, if number of particles, yeah, if solid particles dissociate, dissociate, then value of I will be greater than 1. Sorry, value of I will be greater than 1. If solid particles associate, if solid particle associate, in that case, then value of I will be smaller than 1. Okay, so how do we calculate the value of I? We can understand by giving the one example. Suppose that a substance, a salt AB, dissociate into A plus B minus. Okay, so before dissociation, assume that you have taken one mole. Okay, so before dissociation it was 0. After dissociation, assume that alpha dissociate 1 minus alpha. Okay, means alpha quantity dissociate, means alpha means degree of dissociation. Suppose that alpha amount dissociate into A plus and B minus. Okay, then total particles after dissociation. After dissociation, how many particles are there? 1 minus alpha plus alpha. Sorry, it formed the alpha and alpha. Okay, if alpha quantity dissociate, then how much A alpha quantity, how much B minus alpha quantity. The total 1 minus alpha, alpha is alpha. Okay, so total how many particles is equal to 1 plus alpha, right? Then 1 to factor I is equal to number of particles, number of solid particles after dissociation upon number of particles before dissociation. After dissociation, 1 plus alpha. Before dissociation, 1. So I is equal to 1 plus alpha upon 1. Right? Suppose that let AB AB 80% dissociate. 80% dissociate. Then what is I? What is I? How to calculate I? The I is equal to alpha is equal to 80%. 80% means how much? This is a 0.8. Okay. Then I is equal to 1 plus 0.8 is equal to how much? 1.8. Okay. Assume that it dissociates into n particles. If AB dissociate into n particles. Okay. Then how can we calculate the I? If n particles, suppose that AB dissociate into n particles, then before dissociation it was 1, 0. After dissociation, 1 minus alpha. How many particles dissociate? N particles. Then total how many? How many means particles in a solution after dissociation? N into alpha. So I is equal to what? Total particles 1 minus alpha plus n into alpha. Okay. So in this way we can derive a formula I is equal to 1 plus n minus 1 alpha. This is a formula to find the I. Okay.